5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome, and thanks for joining me today. You know, how many of you remember taking a road trip with Mom and Dad? It was great fun, filled with anticipation, especially having to use a road map to get to our destination. Well, today, through space-age technology, we have navigation that we can hold right in the palm of our hands. We call it simply GPS. It stands for Global Positioning Satellite. In 2019, there were 28,596 GPS in orbit around the globe. But as NASA prepares to travel to the Moon, Mars, and into deep space, how will they determine where they are? Well, I'll have a special report from NASA on an atomic clock to guide our spacecraft. Next on About Space Today. But first, today's trivia question from Rick Potluck, host of America in Space, heard each Friday.
David, here's your trivia question for today. 2 planets in our solar system have backwards sunrise and sunsets. That is, their sunrise is in the west and their sunset is in the east. Which planets are they?
You'll have until midnight tonight to submit your answer to info@aboutspace.today. Once again, submit your answer before midnight to info@aboutspace.today. Are you ready to fly away on a dream vacation? For cruises and all-inclusive resort vacations, call D&D Cruise and Tours at 877-747-8631. That's 877-747-8631. And see us on Facebook, D&D Cruise and Tours, where your dreams become a reality. Welcome back. You might remember our interview with Atlanta astronomer Mark Banks when we discussed how Apollo astronauts used a sextant to check their position and distance from Earth. Well, all that may soon be changing. Here's a special report from NASA on using an atomic clock aboard our future spacecraft.
How do we navigate through space? Currently, spacecraft flying beyond Earth don't have a GPS to find their way through space. Navigators on Earth send a signal to the spacecraft, which receives it and sends it back. Extremely precise clocks on the ground, called atomic clocks, measure how long it takes the signal to make this two-way journey. The amount of time tells them how far away the spacecraft is and how fast it's going. The farther out in space the spacecraft is, the longer it takes to receive and send a signal. But what if humans are sent to another planet, like Mars? A two-way system that sends a signal from Earth to a spacecraft, back to Earth, and then to the spacecraft again, would take an average of 40 minutes. Imagine if the GPS on your phone took 40 minutes to calculate your position. You might miss your turn, or be several exits down the highway before it caught up with you. If humans travel to the Red Planet, it would be better if the system was one-way, allowing the explorers to immediately determine their current position, rather than waiting for that information to come back from Earth. NASA is testing new technology that would allow future explorers to do just that. The Deep Space Atomic Clock is the first demonstration of an atomic clock that can be used for navigation in deep space. It will allow a spacecraft to calculate its own trajectory instead of depending on Earth. If a spacecraft had one of these clocks on board, it could receive a signal from one of those big antennas on Earth and quickly measure its speed and position. The Deep Space Atomic Clock could one day let astronauts navigate safely and accurately to Mars and beyond. This technology demonstration is the first step in making one-way space navigation a reality.
After this report, how accurate are our clocks at home? Remember to invite your family and friends to listen to our podcast and follow us on Facebook at aboutspace.today. And to you, my many friends in the U.S. and around the globe, Thank you for listening, and be safe during these wintry days. I'm David Denault, and this has been About Space Today.